All right, so we're going to start looking at identifying parts from tables. We just talked about arithmetic and geometric sequences in those patterns. Well, we can actually see these kind of patterns through tables as well. So when we're looking at a table here, a couple things we want you to identify are, is it increasing or decreasing? Can you see the common difference or the common ratio? And then is it linear, exponential, or neither? The linear and exponential is going to be tied to whether or not it is arithmetic or if it's geometric. So let me just go through this example real quick, let you try the second one, and we'll call this video good. So let's go ahead and look at it. First thing, is it increasing or decreasing? When I'm trying to determine whether or not a table is increasing or decreasing, I don't care about the inputs as much as I care about the outputs. So the x's and the domain, I'm not going to look at that. I'm just going to take a look at the range for a little bit, the outputs, the y values, and we're going to see what's going on there. First off, I can see how we're getting from 3 to 7, and then from 7 to 11, 11 to 15, and 15 to 19. That is definitely going up, so we're going to call this increasing. And then what is the common difference or ratio? Well, let's try to find a common difference first and see if that works. Remember from our last video, the common difference is either adding or subtracting, and because this is increasing, we will be trying to add first. Going from 3 to 7, that's going to be adding 4. And let's see if this plus 4 or adding 4 works again. 7 plus 4 is 11, and then 11 plus 4 is 15, and then 15 plus 4 is 19. And so you can kind of see how we have a sequence here, and we just have this common difference of plus 4. So our common difference is 4. This is not geometric because we're not multiplying to get to the next term. So we got that. It is a common difference, and we have it as positive 4. And then is it linear, exponential, or neither? Well, remember, because it's a common difference, that means that this is arithmetic. So something that's kind of new for this video is just to show you guys that arithmetic sequences are linear. Okay? And they're linear for the same reason why when we look at a constant rate of change, and when we're looking at slopes of lines, we do have a constant rate of change. This would be 4 over 1, 4 over 1, 4 over 1. Because all the rates of change are the same, it would be linear. And that goes back to a few lessons ago. But that, anyway, just basically proves this. Arithmetic sequences are linear. Right, so let's move on to this these next two questions down here. What is the first term, and then what is the initial amount? And that's probably the most confusing thing from tables. We remember back when we were talking about exponents, that initial amount was represented by the symbol A sub 0, and that's how we represented the initial amount. And basically what that means is, hey, we want to look at where our starting point is, and that's what 0 represents. And on a table, that's just where our x is 0. So where x is 0 is going to be our initial amount. You can think about it this way. This is going to be a sub 0, so our initial amount. So our initial amount in this case is 3, which leads me to talking about what's the first term. Well, if initial amount is where x is 0, then the first term must be where x is 1. And we use the subscript to refer to each term in the sequence. This would be the 0 term, and so the first term would be a sub 1. That's going to refer to the first term, and that would be right here where x is equal to 1. So like a sub 1. A sub 1 then is 7. So our first term is 7.
Cool. So you're saying initial amount is before we start, and then first term is after we've gone 1?
So I would say a sub 0 is where we start, what we start with before anything starts happening. I guess the best way to describe that, I like to go back to bacteria. If you start with one bacteria, you have to start with one bacteria before it starts to multiply, right? And so you can't get the 2 bacteria without the first bacteria already. So you have one bacteria, they have to wait a certain amount of time before you get your first term, which would be the 2 bacteria. And so here, this is what we're starting with. It's like if I have a business, let's go with a lemonade stand, and I started with $3, right? And then each day I'm gaining another $4, right? And so I started with $3 before I even opened up my lemonade stand, and then on my first day I made $4. So that would be how we find initial amount versus first term. Why don't you go ahead and pause the video and try this one out. Same questions, different table. All right, so is this one increasing or decreasing? Well, let's take a look at those y values. Going from 6 to 12, 12 to 24, 24 to 48, 48 to 96. This is definitely increasing. What is the common difference or ratio? In other words, how are we increasing then? Well, let's try looking for a common difference. To get from 6 to 12, I'd have to add 6. Again, we're trying to see if it's a common difference. But if I add 6 again, 12 plus 6 would be 18, not 24. So common difference is out. Now I have to go try to find a common ratio. And again, you can find common ratios by multiplying or dividing, but common ratios are always by what you multiply by. And so I'm going to try multiplying, and 6 times something equals 12, and that is times 2. And then if we try multiplying by 2 again, 12 times 2 is 24. 24 times 2 is 48, and 48 times 2 is 96. So we do have a common ratio because we're multiplying. And remember that common ratios mean that we have a geometric sequence. And that actually helps you with, so we have a common ratio, we talked about that. The next question is it linear or exponential? And we're going to start talking about why these are exponential. We actually have already in our previous videos, and we're going to keep on going with that conversation. But geometric sequences are always exponential. All right, and so what's the first term? Well, just like we talked about, the first term is where x is 1. That is represented by saying a sub 1. And so our first term is going to be right here. A sub 1 is 12. And our initial amount is where x is 0 on a table. So a sub 0. And that is going to be a sub 0 right here. And that is going to be 6.
So a sub 0 is my before I started, and my first term is after I started. So the initial amount is before we start, and the first term is after you've done 1.
Yep. The great example here is because bacteria multiplies by 2 all the time. We would say that I started with 6 bacteria, and after, let's say, an hour or so, we'll just say this is 1 hour. After an hour, we are doubling our bacteria, because 6 bacteria would turn, all of them would double, and they would turn into 12. And then another hour later, they turn into 24. But you have to start with bacteria before they can start doubling. If you have no bacteria, then they can't start doubling. Right? So that's that.